Right. What we learned yesterday? Prasad, what we learned yesterday?
Vectors.
What is vector?
Vector is an 1D array of data elements.
1D array of
Array of
data
data elements.
elements or values. Okay. Can I store multiple data types in one array? Sorry, in one vector.
No,
Can I store?
same data type only.
No, we cannot store it. We can store only same data type. Next. What we learned yesterday still? Only one thing. We know how to do the vector elements read. How we can read the vectors element read. For example, whatever we have the vector, that position we have to go and we have to take it. That gives you how to read it. Now we know
Yeah.
how to update the vector element. All you have to do is you have to go to the position of that vector, whatever we have it, and followed with that one we have to map whatever value you want it, something like that. We are aware of it, how to update the vector, given vector, how to update it, we are aware of it. Okay, and we learned about names function. We have a names function. It is useful. Now what purpose it is? To provide titles to vector elements. Provide titles to vector elements. So because of that one, we are able to provide the titles. We are able to provide. Today we went for playing cards is one example. In the playing cards, whatever we have the clubs, spades, those all things we are able to provide titles properly because of this names function. Because of this names function. Okay, that's what we learned yesterday. Names function. Then we went for anything else. I think that's it. We went with a small chapter. We learned those are the things what we learned yesterday. Today we'll go and try to understand about matrix. In mathematics background, we are aware of it. What is matrix, right? It is vector is what? It's a 1D array. Whereas matrix is a 2D array. Matrix is a 2D array. It also has same data type it can store. Same data type of elements only it will hold. We cannot store some numbers, some strings like that. Even matrix has capability to store the strings, but mostly it has no use. Most of the matrix calculations we are going for with numbers only. But our matrix can store the string values also, it can store it. String values also it can store it. For example, we are writing here a matrix here, let us say matrix, and we are writing here the vector of elements is, let us say C. We are taking here A is the value, comma, B is the value, comma, C is the value, comma, D is the value, and number of rows is equal to 2, and number of columns is equal to 2. Okay, and by row I want to populate the data, so by row is equal to 2. This is what the standard syntax whatever we have it. So what it's going to store now, it's going to store the matrix which has the elements of A, next B, below we are going to get the B, then C, then D we are going to get it. Okay, but it has mostly you are storing here string values, right, which has no use, If the same thing, if I am trying to store, let us say with the numbers, for example, in this place I am trying to provide here 1, I am trying to provide here 1, comma 2, comma 3, comma 4, something like that we are doing it, which is really useful to our calculations. Okay, these two things, this is called as now string vector, this is called as now number vector, and it's not possible like this. What is not possible? We cannot store, let us say, a matrix like this, 1 comma 2, something like that. If you want to store it, somehow things as string values, somehow things as numeric values, we want to store it, that is not possible. Okay, even though this is possible, we may not be using mostly. This is the one what we are going to use in live. More useful one is, this is the one more useful one. Okay, the other thing is, even though you should accept here, it's not that much use, no use in most of the scenarios, we're not going to use in most of the scenarios. Okay, let us go and try to create one simple matrix and we'll see how it will be working. Let us open the notes. So the first point we have here, matrix is a 2D array of elements. They contain elements of the same atomic types. Atomic means here string, number, integer, boolean, logical, those all things will be atomic types. That is basic data types. Basic data types also called as atomic types. Though we can create a matrix containing only characters or only logical values, they are not of much use. Even though it is allowing, we may not be using in most of the scenarios. We use matrices containing numeric elements to be used in mathematical calculations. A matrix is created by using matrix function. We are going to use matrix function for this purpose. The basic syntax for creating a matrix is here. These are the 5 parameters what we have it. First one is we have to provide the data and how many rows we want it, how many columns we want it, and how to populate the data by row or by columns, and dimension names. That means the titles of the values. You can provide using dimension names. Okay, while you're doing this one, the syntax you come to understand more clearly. Right, if you see here, first example, observe below examples. What is the first one we have? I want to populate the data with the vector called as 1:12. 1 to 12 elements are available. That is what the data. Number of rows I want is 4. And by row is equal to true. Even though I didn't define here number of columns, number of rows I defined here 4, right? If I want the 4 rows out of 12 elements, how many columns it has to create? That will calculate internally. Okay, so it calculates 3 and gives to you. So data properly if you define, then automatically system will take care of how many columns you want if you define the rows. Okay, let us go and try to do the same activity. I am giving control to you. Prasad, I am giving control to you. I sent a request. Once you are ready, please let me know. Meanwhile, I will continue. Okay, let me open the R console. Control L to clear the space. Right. Now we want to define here a matrix. The matrix is equal to M. I am saying M. I am trying to assign a matrix. So then what is the function we have to use? Matrix is the function what you have to use it. and I want a vector. The vector of elements is starts with the 1, 2. Total is the a vector of elements. And how many rows I want here? Number of rows I want is equal to, let's say, 4 rows I want it. Okay, I want to populate the data by row. By row is equal to, let us say, we are specifying here true. Then close it, then enter. Now if you type the m, we are going to see m corresponding values. We are seeing it. If you see, I given here by row is equal to true. That is the reason 1, 2, 3. It's came like this. First it is filled the row, then it is going for the second row, right? Suppose if I am giving here by column is by row is equal to false. By row is equal to false. Then if you go and try to see the m, we can observe now output difference. We have here 1, 2, 3, 4 like this we got it. Then 5, 6, 7, 8. Then 9, 10, 11, 12 like that we got it. So this parameter by row is equal to true, by row is equal to false will decides how to take the values. First it has to fill the rows or first it has to fill the columns. It is going to decide it. Okay. Now for example in the above one, if I am trying to say as number of rows is equal to let's say 3 instead of the 4. Now we are going to see here 3 means we are getting accordingly 4 columns we are getting it. Okay. Right. Suppose in the above matrix, let us say I am trying to provide here C, then A, then B, then C, then D. Okay, that is enough. Let us say number of rows is equal to, I am saying as 2, by row is equal to false, then M. Now we are able to see here, we are able A, B, C, D. We can create a vector using string values, but mostly it has no use. Okay. Now if you want to create using the Boolean values also, you can go and you can create using Boolean values. For example, we are writing here true. Okay, and again we are writing here, let us say true, then we are writing here, let us say false, then we are writing, let us say true, then we are typing here m, then we are able to see true, false, we are seeing it. Okay, I think we need not provide here, these codes are not required. If we provide these codes, system is treating like these are string values is treating.
Character.
Yeah, character. So I am removing those things, then press enter, then m. Right, now this is what you are drawn. But this logical vector and this character vector, whatever available, it has no use. We have to go with the number things only. In our mathematics, whatever we studied in the schooling or colleges, whatever we did, mostly we are working with the numbers only, right? Yeah, that's what the first point what we are trying to tell here. Okay,
Ram, what is the use of that by row?
by row, right?
Yeah.
Yeah, see this first two examples. Then we have the first two examples, right? This is a matrix. By row is equal to true I given. Then 1 to 12 whatever values are available, first it is filling what row it is filling. This is called as row, right? It's filling row, then it is going for the second row, third row, like that. If I given by row is equal to false, then what it is filling here? First it is filling column.
Oh, okay, got it. Yeah.
Yeah, how to populate the data, that is decided by this by row parameter. Okay, now with this we completed first two examples. Next one we have here names I want to provide. Yesterday we provided the names, right? By using the names function we provide it, but today we have to use the dim names is the one parameter which is available inside the matrix. First, we are trying to take one vector, row names. There we are storing the row 1, row 2, row 3, row 4 like that. And we are storing here column names is the one vector. See column 1, column 2, column 3, we are storing it. Then we are trying to provide here matrix. See 1 is to 12, number of rows is equal to 4 I want, by row is equal to true, and dimension name is equal to list. Okay, at this point of time, forget about what is this list. I'll talk about this later. List is nothing but collection of different vectors which may be same data type or different data type, doesn't matter. You getting my point? Anyhow, that is our next topic. List is nothing but collection of vectors which may be same data type or different data type. Okay, at this point of time we are providing list of these two vectors we are combining, and we are pressing enter. We are seeing here the output. Let us try to do this one. Yes, Prasad, I gave control to you. Please try to do the statement. First try to create a vector with the row names. Okay, let me adjust this window. Right. Please try to do it. Row names is equal to our assignment operator. Anything is okay. Equal to our assignment operator. Anything is okay. C of so we have the plan of creating here 4 rows. So there is reason 4 titles we are deciding here. Row 4. Then close it, enter. Fine. If you want to see what is the data we have in the row names, just type the row names so that we come to understand properly it is created or not. So it's created and it is olded the values rows 1, rows 2, rows 3, rows 4. Now similarly create one more vector with the column names. One more vector with the column names. Now we want 3 columns only, we want it. That's the reason. Yeah, we want 4. Okay, no problem. Go with the 4. Enter. Now column names. Right. So we want to get 4 columns. Next, create now a matrix. Create now a matrix under pop under assigning to the who is the variable. Then matrix. Then I want a vector of elements. 4 by 4 matrix you want it over there. 4 by 4 matrix means how many elements we required? 4 by 4 matrix you want means how many elements you required? 1 6, right? 16 elements. So give it as 1 is to 16. Right. 1 is to 16. Close the bracket. Then number of rows is equal to n row is equal to 4. by row is equal to true, then dim names is equal to list, list, dim names is equal to list, bracket open, row names comma column names. One moment, let me adjust the window. Row names comma column names. Now here we open the bracket here, right? That bracket is not closed. Now we can close it. Now we can close it. There only you can write the closing the bracket. Write it. Enter. Now type the O. We're able to see properly the headings. We're able to see it. Column 1 and rows 1. Whatever we provided, the headings we're able to see it. And distribution is happened 16. For example, we are writing here. We are writing here 1 is to 12 only given. Then enter. What happens? Error in matrix, number of rows is equal to 4, by row is equal to blah blah, and length of the dimension is 2, not equal to array extend. Array extend. So whatever we given here, dimension length is here, two things only we passed here, that's fine. Internally we have here 12 elements are available. The 12 elements whatever we have it, okay, 12 elements whatever we have it, we cannot map to the 16 positions. That's why it is throwing the error. Am I clear this error message?
Yes. Is there any way? Is there any chance of filling with the empty, sir?
No. No. If you specify here empty, then empty will be filling.
The cell cannot be empty.
Yeah, the cell cannot be empty.
So how about the here by row equals to true recap? That is applicable for only the columns, because by row equal to true means the rows are coming in the vertical fashion.
Right. Rows are first filling like this. Yeah.
Oh,
This is the row. By row is equal to means first one will be filled, then two will be filled, then 3, 4. Row wise it is going to fill the elements.
in that case, in the list class, so the first vector is it's applicable for the first vector. By row equals to true means.
Sorry.
Because here we have the two vectors in the list. The by row equals to true is applicable for the first vector.
By row actually further this data values to organize it.
Because in the list we have the two vectors. No, so in that case, it is applicable to the first vector. In the list we have the two vectors.
No, this is for titles. Forget about this one. This parameter, whatever we have by row parameter is not at all applicable. It's not at all applicable for this. It is applicable for this only.
Oh.
Okay, it is applicable for only this.
Only those values.
Yeah. Here we are going to write first row names, second column names. Always this is fixed. This is fixed. Okay, right. Now let us move on to the next one. We understand here how to provide the titles. How to provide the titles of our matrix elements. Next one, read elements of matrix. Read elements of matrix. For example, we have here a matrix. This is what available. I want to read the element called as 6. How I can read it? What is the position of 6? What is the row?
Row of 2, column of 2.
Row 2 and column 2. So we have to write here O bracket open 2 comma 2. Please write it. Yes, sir. O. Our matrix is O, right? Our matrix is O bracket open 2 comma 2. Is it correct? Enter. What is saying? This bracket is required only for the functions. Okay, other than that one, this kind of bracket you have to use it. The square bracket you have to use it, not the regular bracket. Try to use it, square bracket. Now we are seeing here 6. Let us try to read third row and fourth column. Third row and fourth column element I want it. That is 12 I want. That is 12 I want. Suppose I want entire first row I want it. Entire first row I want it. Entire first row. So 1 comma nothing. Don't provide anything. Nothing. Don't provide anything. Don't provide anything. Then close the bracket. Enter. That means we are expecting entire first row we are expecting. Suppose I want here third row. Entire third row I want it. What will do? Entire third row I want it. Excellent. Suppose I want first row as well as third row both. What will do? First row as well as third row. What will do? If I want two rows, we have to use the vector notation. So C 1 comma 3. C 1 comma 3. 1 comma 3. C is a function. That is the reason this bracket we are using it. Close it and comma. Then nothing you provide it. Close the bracket. Comma. For where is the columns here? Columns you have to provide, right? So C 1 comma 3. Then comma. Close the bracket. Then enter. What is the meaning? I want first row as well as third row, but comma, what are the columns you want? All the columns I want it, right? Same three jobs do for columns. I mean, I want first column, I want third column, I want first and third columns. Try to do it. I want first column. I want first column, that is 1 5 9 13. I want it 1 5 9 13. I want first column. See, whenever you are writing the matrix, first rows, second columns, you have to write it. 1 5 9 13. This is what is the result I am expecting. This 1 5 9 13 means all the rows I want it, but column number is 1 is the column number. So what I have to write it? All the rows I want. That is the reason I am not specifying any row numbers. All the first column I want it, right? So we are specifying first column. Then we are able to see 1 5 9 13, right? Similarly, I want now third column. Third column meaning I want 3 7 11 15. These are the things what I want it. 3 7 11 15. Try to do it. Yeah, excellent. I want, let us say, first as well as third columns both. Then try to write it. First as well as third columns. Yes, excellent. Excellent job. Excellent job. Right. Suppose I want first row, third row, and first column and third column, let us say. How we can do it? First row, third row, and first column and third column. Both the places try to call the vector. What will happen? We'll see. C1 comma 3, bracket open, C1 comma 3, comma C1 comma 3. Comma C1 comma 3. Will it work? If working, what elements it is going to pull it? Okay, there is a possibility of working or not. Just go and try to close the bracket, enter. Right? How it is pulling now? How it is getting the data? 1 1 element. 1:1 means what is the element we have? 1 1. 1 1 means what is the element? First element, right? This is the first element. And 1 and 3. 1 and 3 means what? 3, right? That's what we got here. What we got? 3. And 3 1. Third 3 1 is available. So if you go and try to see 3 row, third row and first column. So we got the 9. Next is what? 3 3. That means third row, third column. Third row, third column is how much? Third row, third column is 11. That's how we got here 11. Is it clear now? If I ask any element to read it or a set of elements, can you read it or not? And this result, whatever we have it, I want to map to the, let us say, P is a one more vector, I want to map it. P is a one more vector, sorry, one more matrix, I'm sorry. P is a one more matrix, I want to map to that one. Now, go and try to type the P, we are able to see the P. So, subset of matrix, we are trying to create it. From one big matrix, we are trying to create a subset of matrix, we are trying to create it. Got my point? So that's what exactly we are trying to do in the reading of the elements. Read elements of matrix. First comma, third, first row, third column. Here entire third column. Here entire first row. Here third row, third column. Here first and two second rows. Okay, and column is second column I want it. And here second row, first and second columns. And like this we are writing here, we are seeing it, right? Is it clear?
Yes.
Yeah, it's clear.
Right. Now let us move on to the next one. Matrix arithmetic calculations. Arithmetic means we are aware of it. We have the plus, minus, this kind of things is called as arithmetic. So let us say we have a matrix C1 comma 4. So 1, 2, 3, 4 like that. And Q is equal to 5 comma 8, 5, 6, 7, 8 like that. Then P plus Q we are doing it. So first element here will be mapped. So 1 plus 5 that is 6. 3 plus 7 that is 10. 2 plus 6 that is 8. That means the position wise it is going to sum up. Are you getting my point? And P minus Q, P into Q, P by Q, Q by P, whatever way you want to do it, you can do it. Please try to do that activity. Create two matrices and try to sum it. Yes, sir, Prasad. Create two matrices. Go to the R. Right. So go and try to create your matrix. Yeah, go ahead. P, we are write a assignment operator, then matrix C1:4. Close the bracket, the number of rows is equal to 2. Then enter. Then type the P. Now go to the Q. Go to the Q. Give the Q. Then values as 5 to 8. Then enter. Then Q. We are able to see P and Q data. Then P plus Q. Now we are able to see properly data P minus Q. I hope we are able to understand the data whatever we got it, right?
Yes, yes.
Right. Now E into Q, then P by Q, Q by P, whatever you want, you can write it. So this is how we are going to do simple arithmetic whatever you require. Right. So that's how we are doing it. Let us move on to the next one that is called as construct and transpose a matrix by interchanging its columns and rows with a function called as T. T is a function. If you don't know any function, already we are aware of it. What you have to do? We have to go to the help document just by typing the question mark and T. It is going to give you T corresponding whatever we have it. Given a matrix, RT returns the transpose of the X. So T of X we are going to write it, and the details and bottom we can see even one example also we are able to see it. Okay, AI of J means it is equal to, it is going to give what? J of I it is going to give it. That means it is going to reverse the objects. Okay, let us go and try to do here. Fine. We are creating a matrix now with 1, 2, 3, 4, 5, 6. Number of rows has 3. Number of columns has 2. Yeah, go ahead. Matrix. Then 1, 2, 3, 4, 5, 6. Two times 6 is game. Length is available 7, but as per that 6 only should be there. So remove 1 6. Use the keyboard left and right arrow marks. Now print the B. Now T of B. Write the T of B. Then we are able to see what is the T of B. Okay, next one. We have here C bind. Column bind. C bind means column bind. Bind means you know already, right? Making together. Making together. Column bind means it is useful to add the columns to existing matrix. For example, we have the B. This is what the B, and I am creating here one more matrix C with the number of rows is equal to 3, number of columns is equal to 1. So total here, how many columns we have here? 2. How many columns we have here? 1. These two things I want to combine here. So 2 plus 1, how many columns it becomes? 3. So if you want to combine the columns, you can go and you can do that. So try to see the execute one by one step and see the output. First execute the B. Already we have the B, same thing. So try to execute the C. B is already we have it. So type the execute the C. Right. Enter. Then we are able to see here one column is available. In the B, we have the two columns are available. Those two things we are trying to combine here. Then go for the D is equal to C bind B comma C. Careful. Right. Now try to enter the D. We'll able to see one column is extra added. We have the B result is this one, C result is this one, but D result is this one. If you see all three things at one place, you are able to understand it. In the B, we have here only two columns are available. In the B, we have here two columns are available. In the C, we have one column. So in the D, we are able to see B and C and whatever we have it. So that's what we are doing here, C bind. C bind means columns we are going to bind together. Columns we are going to add together. Now similarly, we have here one more function that is called as, what is this?
Row bind.
R bind. Row bind. Okay, it's going to combine the rows. Let us say I have here R bind matrix we are creating here. Then this is the one matrix we are creating it. And number of rows is equal to here 3, number of rows is equal to here 1. In my resultant matrix, I am expecting number of rows is equal to 4. But here one thing we have to make sure is, whenever we are adding the rows, number of columns should be constant. Both the places it should be same. Number of columns in two matrices must be same. Then only I can go and I can combine it. Okay, try to do this activity. So I think already we have the B in place. Okay, then we have to go for the some E I created here. Try to create the E. E is equal to matrix. Then number of columns is equal to 2. Right. Then enter the E. That's what the E data. Enter the B also. We'll see the B data. Right. Now we want to combine this B as well as E. In both the places number of columns are same. Now F is equal to R bind B comma E. Then enter. Now print the F. We're able to see it. For example, I'm writing here whatever we have the E number of columns is equal to, let us say I'm fixing here as 1. I'm fixing here as 1. Number of rows is equal to 1. Number of columns also 1. Then type the E. Then we are getting here like this. Only 20 only it is taken, 30 it is not taken. Let it be. Now can I combine the both the things? What is saying? Number of columns of matrices must match. The reason behind the E matrix we have here only one column. In the B matrix we have two columns which is not matching. Hence it is throwing the issue. So if I want to do the row combining, then in the two matrices the number of columns must be same. The number of columns must be same. Now next one is available, deconstruct a matrix. Deconstruct a matrix by applying the C function which combines all column vectors into one. Okay, so it is also called as converting a matrix converting a matrix into vector. Converting a matrix into vector. Okay, you can write that point also here. Okay, ORR converting a matrix into vector. So we can say like that also, you can say it. Okay, so we are trying to see the B data first, and the B data we are converting into the single vector. Let us go and try to see it. See the B data, type the B, enter. It is a matrix now. Now let us say HH, then assignment operator C of B. Already we are aware of it. C is a function. It is useful to create the vector. So it is creating a vector by using the elements of the B matrix. It is creating a vector by using the elements of the B matrix. Same concept, we are calling it as deconstruct here. Then enter. Then we are able to see 1, 2, 3, 4, 5, 6. Is dot vector of x. Just write it. Is dot vector of h. Is dot vector of h. Then what you are seeing, it is a true. If you want to read the fourth position one in the h vector, h fourth position, h bracket open fourth position, enter. Now we are able to see fourth position one, we are able to see it, that is 4 is available. So it is a purely, it is a vector. It is useful to convert now matrix to vector. It is useful to convert matrix to vector. Right, that's excellent. Now for more information purpose, I given here 2 blogs I given. One is RTutor, second is official R project site. Any one thing you can go and you can see more about this one. Okay, but this is what enough to understand the down the line whatever programming things are going to write it. Am I clear? So let us go and try to walk through once RTutor what we have. So this is RTutor. So a matrix is a collection of data elements, blah blah. We know that one. How to create the matrix, then elements, how to read it. Then we are trying to give the names here and matrix constructions. So it has a number of rows, transposing, combining the matrices. We know combining how we are doing it, right? So C as matrix, blah blah. Now we are trying to combine here C bind using, then we are using the R bind function to combine the rows, blah blah, and deconstruction like that we are doing it. And also go for one more material, not whatever we have it, it's official guide, you can go for it. One more point is, instead of going for these many materials, right, you can go for here itself or documentation that is called as, what is it, what is the matrix you want more information is what you can do. Yeah, help, you can go here and type question mark and matrix, you are going to get the help here. So that gives you minimal information whatever you required it. Okay, and you can see in the bottom examples also we are able to see it. If you are able to execute these examples and you are able to understand it, that is enough, you are up to mark about that concept. Got my point?
Yep.
Okay, so that's how we are going to learn the R down the line. Now next one is available, that is called as factor. That is called as factors. So we'll cover these factors as well as lists tomorrow.
Oh,
Thank you. Right. You
yep, sir.
complete the installation?
Yes, yes.
Rajesh, is it the first class for you?
Yes, this is the first class.
Okay. Whatever you missed the classes, those classes are available already in the YouTube. Okay, you can go on
Okay.
and get it. Let us go for So here we are seeing data science tutorial part 1, right? Part 1,
Yes.
part 2, part 3. These 3 videos you have to listen.
Okay.
Okay. Just you type similarly
Yeah.
whatever I type, data science by RRITEC. You are going to get this videos. You are going to get it.
Okay. Thank you.
Thank you.
Ram, tomorrow Saturday, right? Tomorrow it's there, right? Class.
Yeah, up to you people. If you want, we'll keep it, or else we'll stop it. I have no issues.
Okay, stop.
Stop it? Okay, we'll stop it. No problem. So we'll meet again on Monday. By Monday, please try to install the R. Okay, and be ready with this one. These all things, whatever I'm explaining now, it's a basic things. Basic things. Tomorrow, if I written one big program, okay, then you should be in a position to understand what exactly we are doing it right. So at that moment, it will be more useful to you. Okay. Suppose here we are writing here one program we are writing it. To understand this program, what we are doing it, then we require is all things we required it. Okay. Please try to get these all 5 concepts are available. One is called as vector. Second is called as matrix. Third is called as list. Fourth is called as factors. And we have the data frames. These 5 concepts are the basic concepts. Okay. Thank you. Please try to prepare with that. Bye bye. We'll meet again on Monday. Thank you.